Nobody talks about what happens to your creatine when you get sick, but it's worth knowing because the relationship between illness, creatine metabolism, and recovery is one of the more practically important pieces of this molecule's biology that consistently gets overlooked. When your body fights an infection or recovers from physical illness, energy metabolism changes substantially. Your immune system is energetically expensive. Lymphocyte proliferation, cytokine production, fever generation, and the acute phase protein response all consume substantial ATP. Mitochondrial function changes under inflammatory conditions in ways that affect efficiency across tissues. And muscle tissue is hit particularly hard. Illness-associated muscle wasting, loss of lean mass that accompanies even relatively mild systemic infection, is driven by a combination of reduced protein synthesis, increased protein breakdown, reduced physical activity, and reduced caloric intake. Creatine stores in muscle decline during illness for several reasons. Reduced dietary intake during illness means less creatine coming in from food sources. Elevated whole-body energy expenditure during fever and immune activation increases the rate at which phosphocreatine is used across tissues. Muscle disuse from bed rest or reduced activity accelerates the decline in muscle creatine content. The metabolic shift that occurs during systemic inflammation can also affect creatine transporter expression. Some evidence suggests that inflammatory cytokines may downregulate creatine transport in certain tissues. The net result is that emerging from a significant illness, your muscles are likely holding less creatine than they were before you got sick. And because phosphocreatine is part of your energy system for any physical activity, this contributes to the fatigue and weakness that characterize post-illness recovery, separate from the loss of muscle protein itself. What does creatine supplementation do in this context? The research in clinical populations is meaningful. In hospitalized patients with various conditions, creatine supplementation has been studied as an adjunct to recovery, with evidence suggesting benefits for preserving lean mass during periods of forced inactivity and reduced intake. In conditions associated with chronic muscle weakness, including certain neuromuscular diseases, creatine supplementation has shown modest but real benefits for muscle function. For healthy adults recovering from ordinary illness, the practical application is straightforward. Maintaining creatine supplementation through and after illness helps preserve the stores you've built, reduces the magnitude of the post-illness performance decline, and means you're rebuilding from a higher starting point when training resumes. Stopping creatine during illness because you're not training is a common but counterproductive decision. Your muscles are still depleting their stores. The creatine loss during illness isn't prevented by stopping supplementation. It's made larger because you've removed the one input that was helping to maintain your stores. Starting or resuming creatine after illness, combined with progressive resumption of training and adequate protein intake, is the most efficient path back to your pre-illness performance baseline. The phosphocreatine system recovers as your muscle creatine stores refill. Your training capacity returns as the energy buffer rebuilds. And the weeks you spent sick don't erase the months of training you put in before, they just require deliberate rebuilding. Creatine is one of the tools that makes that rebuilding faster and less costly in terms of performance regression. Not glamorous, men, but the biology is clear, and the practical decision follows directly from it. There's a broader principle here that goes beyond creatine specifically. Illness, injury, forced inactivity, and periods of significant psychological stress all have metabolic costs that show up in muscle tissue even when the event feels unrelated to training. Creatine is one of the few supplements with a biological rationale for use during and after these periods, precisely because it's addressing an energy substrate that gets depleted by systemic stress, not just by exercise. The evidence base for creatine in clinical recovery populations is growing. Studies in older adults recovering from hip fracture, in cardiac patients during rehabilitation, and in individuals with conditions like Parkinson's disease have all examined creatine's role in preserving or rebuilding lean mass under conditions of reduced physical capacity. The results are not uniformly dramatic, but they're consistently in the right direction. Supplementation supports lean mass preservation, reduces fatigue, and in some cases accelerates functional recovery compared to placebo.